This is a proof of the product rule from scratch. So I'm going to take what's called the product rule. I'm going to rewrite this right here. Product rule from scratch. Okay, so what I want to prove is right here. You can see that I want to see the derivative of a product. This is the product of a f of x times g of x. And with respect to, I got another missing parentheses here. They're missing g of x. So I'll just put it like that, okay? So I have f of x times g of x. I want the range, the slope of that product. And I want to show that it's equal to this. That this is what I'm trying to prove. The way I remember it is like you leave this first guy function alone, and then you tickle the second guy, I call it tickling, and that's g of x. And then with the next plus, then this time you tickle the f of x and you leave the g of x alone. So we're given that both f of x and g of x are continuous functions. Are continuous and differentiable. So using the definition, I'm changing some of the letters here just to make it more legible. Not that it's really much better anyway. Definition of derivative. So first we'll let f of x, capital F of x, equal the product of f of x and g of x, you see. And then there's a definition of a limit of a continuous function, or it's the rise of the run is the definition of a derivative. It's really a slope. And so these are the y values up here, which are, these guys right here. Measure the rise, and this little h guy here would be the run. So if I take the limit of that, as h gets smaller and smaller, then you can see that f of x plus h will get closer and closer to f of x. And that limit, we call it this guy right here, the derivative. We call it the derivative as defined to be the rise over the run as h approaches 0. So another way of saying that is over here. I'm just saying that this is equal to this. If I now I'm going to take f of x, remember what I let it equal to. So f of x is right here. See it? So capital F of x is equal to little f of x times g of x. So I'm just going to replace capital F of x with what it equals to. And since the argument is x plus h, you see right inside, then the little guy over here, I'm going to replace with x plus h right here. See it? And then I'll replace that. Minus, and I leave these guys alone. They don't have an h in them. And then all over h. So that's the setup. That's just plugging in from over here, from this guy. Okay. Now I have a trick. We're going to subtract and add this term. This guy right here. Now if I add it and I subtract it, that's another way of saying 0, isn't it? If I would take this and then I were to subtract, let's say this same term, right? F of x plus h. And then I got, and I'm going to subtract times g of x. You can see that's a fancy way of just saying 0, right? 0. So now what I'm going to do is introduce that, right? And I'm going to put it right in the middle here. So I'm going to take the limit of the two, right? And then I'm going to subtract this guy. So here I'm going to subtract this guy. And then I'm going to add him back up. See? There I added him, and here I subtracted him. Basically, I'm going to put a minus here and a plus here. See? It still equals to 0, doesn't it? So this middle term is nothing but 0, this guy right here. If I take that minus all of this, minus all of that, I'm going to get 0. It's just another way. And then I still have this guy back here, right? Which is this last term here. See it? So there you have it. So now all I'm going to do is run my limit through. So I have my limit here. So if I take a look at it, then what I've done is just use my limit on this first half, and then I distribute my limit through here to the second half. So it's like, actually the way I have it written is probably better since I've plugged it in. I really should have the limit here, right, as h goes to 0 as well. Well, no, let me go back. That's okay. Now I'm going to run my limit through. So that's what I did here. I brought my limit here. Then I ran it over to this plus. So using this plus sign here, that's this plus sign here. And so I just distributed my limits through two parts of it. So I got my limit of this guy. I just put the limit here. See it? And then I put the limit on this guy. There it is. There it is. Now, if you take a look at this, then we have factors in common, right? I have this guy in common, and then I have this guy in common, right? So if I factor this guy out and distribute my limit through, that's a property of limits. I can do that with products or addition. So this is particularly easy, right? Because if I let h go to 0, then this term right here goes to 0. So then I say f prime of x is equal there. But look at this guy here. That is the definition of derivative of g of x. So that's why I wrote right here just g of x prime. And now look at that. This g of x, I let the limit go through, right? I pulled out, there's a g of x here, and there's a g of x. I can factor out that g of x. And that g of x goes right through the limit because there's no h in it. And guess what this is? This is the definition of f of x. See it? That's by definition. So here I have g of x, right? But this thing is f prime of x. And that's what I wanted to show. See it? Ta-da! That's what I wanted to show way up here. If you take a look at the top, I wanted to prove that this guy, which I let this guy here be capital F of x, see, is equal to f of x times g prime of x plus f prime of x and g prime of x. So the order looks backwards, but there's no reason why I can't change these guys to write it like this. I can write this as f prime of x times g of x, just to keep the order. It's the same thing as multiplication is commutative, and I would just change my arrows over here and put it right here. There we go. Yeah, right there, so that this guy, everything in here, right, becomes my f prime of x, and over here, this is my g of x that I just carried down, and there it is. Okay, I hope that helps some without confusing you. All right, thank you.